Hey, what's up, chat? Welcome to Unit 9, Day 4. In this lesson, we are finding the probability of two independent and two dependent events. So what we're doing is we're combining what we've covered in the last two lessons all in one. All right, so let's start by reviewing and making sure we can make the distinction between independent and dependent events. Okay, and so what I want you to do in the first box, I want you to pause the video and I want you to determine if the event is independent, remembering that it does not change the probability of the outcome. It does not affect it. The first one doesn't affect the second one. Or dependent, where what happens the first time does affect the possible outcomes for the second event. All right, so hey, go ahead and pause it and let me know whether or not these are independent or dependent. Okay, so a spinner with 4 sections and a coin is flipped. When you spin a spinner and then flip a coin, does spinning the spinner has anything to do, or does it affect the flipping of the coin? The answer is no, so that is independent. That is independent. All right, when you have a 2 6-sided number cues, right, 2 dice, when you roll them, right, does one roll have any effect on the second roll? The answer is also no. Therefore, it is independent because those are not affected. Okay? A card is drawn, it is not replaced, and then a second card is drawn. Because it is not being replaced, therefore, you're going to lose one card after drawing. So, therefore, it is dependent. Okay? It is dependent. A piece of candy is chosen, eaten, and then the second piece is chosen. Well, again, because I am eating one, I am therefore losing one of the outcomes, so therefore it is dependent. A letter from the alphabet is chosen, and a number between 0 and 10 is chosen. Okay. Choosing a number in the alphabet and then selecting a number. Okay, those have no effect on each other, therefore it is independent. And then lastly, a 6-sided number cube or dice is rolled and a coin is flipped. Again, rolling a dice, flipping a coin is not going to affect, so therefore it is independent. Okay? And so, again, the key between independent and dependent is that for dependent, one item is being removed and is not being replaced. All right? So, hey, the steps for finding two independent and dependent events are the exact same. First, we are going to find the probability of the first event. Then we are going to find the probability of the second event. And then we are going to multiply these two. And then, in the end, we're going to simplify or reduce. Or if we, our answer choices is written as fractions, maybe we need to find the equivalent decimal form if we're using our Desmos calculator. All right. So, hey, really all of these problems you can do on your own. So I would really encourage you to make sure that you are pausing the video before each question and then do it yourself. And then just use the video to check it and make sure you got it right. If you didn't get it right, then you can listen to the explanation. All right. So go ahead and pause and then do either all of them and then use this to check, or you can go one by one, whatever floats your boat. All right, so what is the probability that is going to land on the A, and then the coin will land on heads? Okay, so we are looking for the probability of getting an A times the probability of landing on heads. The probability of landing on an A is I have 1. It's 1A out of 1, 2, 3, 4, 5. Okay, so it's 1 out of 5. We're going to multiply that times the probability of landing on a heads, which is 1 over 2. And when I put that into the Desmos calculator, I'm going to get 0.1. All right. Question number 2. Hope you've paused it and answered it. Here we go. What is the probability of drawing a red marble, then a green marble, without replacement. That is the key, all right? So we got the probability of getting a red marble times the probability of getting a green marble, okay? We got 10 out of how many total? We got 20 total times the probability of getting a green is 3, but because we did not replace it, this is dependent, okay? And so therefore that is 19. And I probably should, it might be helpful for when you start doing these problems is to find out whether or not it's independent or dependent. That way you know if your total is going to be changing. Okay, so probably should have did that. All right, make sure you do that for the following ones. All right, and then I multiply these. Okay, 10/20 over. I'm sorry, that is incorrect. It should be 10 over 25. I missed that one. Okay, so over 24. And then I multiply this, and I'm going to get 0.05 there. All right? And that's 20. That's 25. Sorry about that. All right. Moving on. Question number 3. All right. Again, hopefully you've read this. Okay. Again, not replacing it. Therefore, it is a dependent event. All right, and then what's the probability that we are getting a blue? And then the probability of getting a red after not replacing it. Okay, so I have 5 blue out of 25. So I got 5 over 25. Okay, then I got 12 red. And again, I'm taking it out and I'm not putting it back, so therefore I'm going to lose 1, and that's over 24. Then I plug this into Desmos, and I will get 0.1 again. All right. Pause. Jacob had a 6-sided number cube. He has a dice. What's the probability that he rolls an even on the first number? And then what's the probability that he gets a 5 on the second number? Okay, well, even, right? This is going to be independent, right? Because I got a dice and those don't affect each other, okay? Even, I got 3 because 2, 4, 6, right? So 3 out of 6. Actually, let's again. These are all the numbers that are on the dice. I'm just showing you. You probably know this. Again, those are the ones that are even, all right? And then probability of getting a 5, if there's only one 5 out of 6, okay? And then I multiply that into Desmos, 3 6 times 1 6, and it is gonna give me 0.083 repeating. All right. Moving on. All right, we're looking for, all right, what's the probability? Again, we are giving it away here, so that is going to be dependent. Okay. All right. And it tells me the probability of each of them. So this time I'm finding the probability of getting a blue, then the probability of getting a green. Okay. So the probability of getting a blue ticket is 40%. Now, when you put 40% into Desmos, it's going to ask you of what? And we just need to say of 1, right? Because when you have probability as a percentage, it's it's out of one whole. Okay? Times the probability of getting a green. The probability of getting a green is 30%. And again, it is going to ask you of, you need to put of 1. So this time, this was a little different because it gives us the probability as percent, but still, we're just finding the probability of blue, which is 40% already given to us. Find the probability of green, 30, which is already given to us, and we just multiply those. All right, and that is going to give us 0.12. All right, and then last but not least, okay, I am replacing it, so therefore it is an independent problem. And then I'm looking for the probability of getting a green, and then the probability of getting a blue. Okay, and so the probability of getting a green is I got 5 green out of the 20 tiles, times probability of getting a blue is 9 out of the 20, and it stays 20 because I replaced it. And then I plug this into decimals and I get 0.1125. All right. Hey, hopefully this has helped you, and by now, hopefully you got it. All right. And we're gonna we just got one more lesson in Unit 9. So in this lesson, we've learned how to find the probability of both independent and dependent events all together. All right. Hey, make sure when you're reading these, you take your time, you break it down, and then make sure that you write out what you're finding the probability of. Those steps are going to help you every single time.